Good morning, everyone. Looks like we can get started. I made a classical presentation mistake that I left my clicker open in here, so the battery is dead. I'll come back here a couple of times to click next. So, welcome everyone to this talk about what happens after you've had a website or a server of yours get compromised or get hacked. There's a couple of ways or degrees in which you can get hacked. We'll get into that a bit more. So this isn't going to be able to cover all of those scenarios because there's a wide range of being compromised, just being data stolen, to more clickers. Thank you. I should have asked this sooner. I will keep talking while I'll try to fit all these dongles. Modern day Mac, such a joy. Thank you very much. So what are we going to talk about today? First of all, what happens if you actually get compromised? What happens to your server, to your app? What kind of special code do they add to your code? How do they do this? They obfuscate their code, they hide it. So we'll look at a couple of techniques to see how you can hide your own code, either accidental or on purpose. I'll show you PHP shells and some clever ways to ground code or make it look like legitimate code, even though it isn't. After we've looked at those certain scenarios, you'll have a better understanding of what happens after someone gets into your application or server. So you can have more ideas on how to prevent it in the first place. You have to know what happens if you want to prevent it. And if the worst thing had happened, your website has been compromised, how can we clean it up? How can we make sure that we remove the hack and all of the traces belonging to it? What am I not going to talk about, just to get the expectations right? I won't tell you how to hack a website. Plenty of courses already do that. I won't tell you how to DDoS a website. $5 credit card can do that for you. And I also won't tell you how to find your own insecure code. There are plenty of code sniffers out there that can do that for you. So if this meets your expectations, by all means, stay where you are. If this doesn't, I won't hold it against you to leave the room. So feel free to. Now, who am I? My name is Mattias, manager at Nucleus. We are a managed hosting provider, so basically we take care of the servers that can run your application. Chances are there's a pretty good chance that we manage one or several of the servers that host your current websites. I used to be a PHP man, but I lacked the time to do active PHP, so I come from the PHP 4 era. You'll see in a second why that's important. And I have a Linux background. I know a bit of Windows, but I'm mostly a Linux man, and I live at the terminal. This is part of my team, just to show you we're all a bunch of happy geeks. But this isn't why you're here. This is why you're here. You have been hacked. Your website has been compromised. Your application has been compromised. Why? Why were you the target? What are they going to do with your compromised website? First of all, they're going to try to steal or potentially steal your data. Now, this is perhaps an odd topic because stealing your data might not be as valuable for website A as it is for website B. If you have a blog, most of that data is probably going to end up publicly, so who cares if they steal your data? Or there might still be email addresses or private information or login information on your website that an attacker might care about. Now, if you're a financial institution, getting access to a website is a lot more valuable because you can do inside trading. You can have an idea when to buy or sell stock. One of the more likely scenarios that we see a website get compromised is so that your site can be used to attack other sites. Your site in itself might not be very valuable. Sorry, from a technical point of view, of course your site is valuable. But it is a very valuable means of attacking another system, so that it looks like your site is actively attacking websites on the internet. That means your reputation, your IP address, your name is going to end up on spam lists as an attacker. You don't want that either. Or it can be used as a command and control server, meaning if there's a botnet out there, it will report back to your server, your website, asking for commands. So you could have a couple of 10,000 servers hitting them saying, hey, who do I need to attack? And then your system, acting as the command and control system, will say, attack website A. And you command your army, or the army of the attacker, to attack an unknown website. So in this case, your website is only playing a very limited role, but a very crucial role in the attack scenario. But what we most likely see, your site is going to end up sending spam, hundreds of thousands of emails. This might not seem a good idea in 2017. We have spam filters, we have proper email protection, yet this still happens, and this is the primary thing we see on servers. If they get hacked, it is going to be is on a good hosting provider, it has a legitimate IP, it has good reputation of its IP address. So chances are, chance of arriving at a destination that, say, those hacked from China. So there is still value in your application, even if it is to send out just spam. So those are the what can happen or while they use your website or server. But let's look at a bit of code and a bit more technical. First, what an attacker will do if they manage to look at your website and find vulnerabilities. First things they're going to try to do is upload additional files to your system. We'll look at how that looks and how that can be abused later on. If they can't manage to do that, they'll find ways to modify existing files. So in your Drupal installation, you'll find function files that suddenly have extra lines of code that you did not write. Or they'll do SQL injection to your system, either to add more data, as in add iframes or script tags inside of existing content to hit your visitors, or to steal your data, perhaps get data out your... How do they do this? Most of the attacks we see today are 90% or more automated. Means someone, and let's call them script kiddies, that's usually how this starts, launches a tool called Havish or SkipMap or any of those popular scanning tools, and it points it at your website. What this tool is going to do, it's going to take a couple of hours and it's going to try every possible variation of your website. It's going to try random get parameters, random post parameters. It'll find every easy to find potential exploit in your app. Once this runs, and this is just a click of the button and then you go have a swim and you come back, then the attacker has a much more narrow attack. It'll have a list of say 10, 20, 50 potential URLs that it can look at in more depth to find how it can be exploited. Up to this point, everyone can do it. This is really simple. These are open source tools. They are free to use, of course, on your own system, not on someone else's. But you can launch this today and find what is potentially wrong on your server from the outside. Not looking at the code you wrote, but what do you expose to the outside? Once you have that, someone is going to try to abuse that vulnerability, potentially for profit. Those are the scenarios we saw earlier. So what will I show next? I'll show you the file upload abuse. What can an attacker do once they manage to get files onto your system? And I'll show you what can happen if someone manages to secret your system. There are a lot of different attack scenarios. If you've ever heard of OWASP, I highly recommend checking out the website, or if you haven't heard of it. There are cross-site scripting. Security in general is a very interesting topic, and I highly suggest or recommend you look into it, if only to broaden your horizon. Now, file upload. Someone has managed to find an upload vulnerability on your system, and they're going to be adding files to an existing Drupal installation base that you did not want. There are a couple of file names that stick out in this case. First of all are the obvious ones. You'll suddenly be browsing your directory, and you'll find scripts called hack.php or shell.php. This actually happens a lot less nowadays, but up until 5 years ago, this was really common. I still don't know why, because these are really easy to spot, especially if you know the Drupal structure. This does not belong there. Alternatively, someone will generate a random file name and drop that file in some kind of directory. These are also easy to spot because no one, at least I won't, in my right mind will name my files like this. Now the reason they do this is they will try to upload a file and access it remotely. If you call all your scripts hack.php, chances are someone else is going to find it as well. This makes it a bit harder and a bit more secure from an attacker point of view. Access this file because no one knows that file name, only the attacker knows it. But what is actually going to be more likely is that they are going to create file names that make sense. Let's say a thumbnail.php file. It might not belong in your uploads directory, but by just glancing at it, thumbnail.php doesn't look all that bad. It might actually be a legit file within your base. If you happen to run a WordPress site, you'll find WP version files to manage. WordPress does this by default, so if you find those files, perhaps not in the right place, glance over it and think, okay, this might actually be legit. Let's not spend a second thought about it. So these are the three main areas that we will find if someone drops a file. These are the file names or the patterns that you can be looking at. If someone doesn't manage to add a file, maybe they'll be able to modify a file. There are a lot of default files in any installation, whether it be Drupal, Joomla, WordPress. From an attacker, it's easy to understand what framework you are using from the outside, so they'll have a better understanding of the directory structure and file structure you will be having. So they'll know there will be a index.php file. They know there will be a site structure with a potentially gettable directory structure behind it. This makes it a lot more easier for an attacker to guess which files are potential targets to add content to. Now, I mentioned I'm not going to talk about how it is, but if you run a system, chances are existing files are going to get extra text or PHP appended to it. And that is the code that gets executed every time your site gets. Alternatively, and this is more tricky to find and report on, they might try to add more content to your database. This means that if someone finds a SQL injection vulnerability and they don't manage to use it to, say, elevate their privileges or create additional admin users, they might try to look at existing pages or blog posts or content and add additional content to it. Iframes, tags, anything that a visitor on your website might actually trigger. This might actually trigger a browser exploit if someone's using an ancient browser. But that means your website, the one you are meticulously crafting, suddenly injects code into the visitors that trust your site, and it will be a valid HTTPS domain or certificate. It will be a valid domain, but it's not the content you intended to have on that system. And this is very valuable from an attacker's point of view because you have trust, your website, your application has trust, and an attacker is abusing that to hit all of your visitors, not just your server. Malicious PHP, or PHP that has been put on a compromised server. What does this look like? It cannot get more cliche than this. This is the kind of code that we find on compromised servers. Compromised meaning someone has run a very ancient version of Drupal or Joomla or WordPress. Someone found a rather easy remote exploit, a plugin that hasn't been updated, for instance. They drop files, and this is what it looks like. This is sort of the PHP that I wrote when I started. It's probably the PHP I write today, which is why I don't do this anymore. This is legitimate PHP that just looks like crap. But it works. It works on pretty much every PHP version you can find today. There is nothing clever about this. There is no dependency injection container overloading. This works on PHP 4, and chances are it'll work on PHP 3. So there's a really low barrier that an attacker has to make sure that if he or she manages to upload. So this is really pretty. This is also the kind of code that we regularly find if a website has been compromised. It's actually code that wouldn't work anymore on PHP 7. But up until PHP 5.6, which is still, I think the 5 branch is still the most active one that we'll find on the internet today, you'll find this one very interesting. There used to be a preg replace parameter that, or modifier that had the /e that could execute additional functions, callbacks, and you name it. This has actually been deprecated in PHP 7 and replaced with the actual preg callback. But this was a really interesting way to hide code. So this is just a string that is really valid with all of the characters escaped. So this is valid code that will match everything because we match everything, and then we'll execute that code. You don't know what this does until you start decrypting it, but this is the kind of code you'll find on a system that has been compromised. And there's more of this, of course. The uglier, the better. The more basic, the better. We have antipatterns. We have someone trying to hide their logs. This is all code that was probably once properly formatted, minified, thrown up on a server, and used for exploits. And what is really cool about this is they use a lot of ways to hide the actual content. They won't say, download file, hack this, execute that. They'll try to obfuscate their code by wrapping it in characters, so just an ASCII character like this. I don't know it by heart, but it'll be A, B, C, or D. An entire file like this, if you start decoding it, it'll become readable. If you don't decode it, this looks like garbage. But will still, in fact, work. There's also pretty. after it has been compromised. But that is not the primary goal of an attacker, to write pretty code. They want to write functional code with as little effort as possible. So there is less pretty code. Who gets the reference? So that's the major. Okay, too far-fetched, never mind. Obfuscation techniques. So you have your pretty code. How would you go about obfuscating it, or how would an attacker do it? There's 3 different ways or goals you have if you do this. One is to legitimately obfuscate your code. You may be writing a PHP application with your goal being, I will give this code to my client for them to run, but I'd rather not have them look at the source code. You can obfuscate it with tools like ZendGuard that basically encrypt your files, then you decrypt it on the server, and if you look at the PHP files themselves, they are gibberish. And you can do it to protect your proprietary code. This doesn't really happen much in, say, Drupal or WordPress or any open source project, but it does still happen in the PHP world. Also accidentally obfuscate your code. If you are a beginning developer, you might write code that is not exactly efficient or clean or up to modern standards, and it can look like obfuscated code. It's really not apparent what your code is doing until you start deciphering it. Or it may be something that you try simple problems that you try to solve in a complicated way because you don't know that there are built-in functions or so to make this easier. So these are the legit or accidental ways you can obfuscate your code. Obviously, an attacker will do this for different reasons. They don't want their code to be found with simple regular expressions or greps or searches on the system. They'll also obfuscate their own code to hide backdoors inside of their backdoors. So if someone managed to upload a PHP file on your system, and say it's a shell, and we'll get back to that later, that shell might not be the only code that is actually on the system. Smart people usually write these kinds of exploits, and dumb people are usually the folks that are executing the exploits. The smart people, being smarter than the dumb people, they'd like to have access to that system as well, so they will hide code inside of their own code that someone implementing the code might not know about to get access as well. But mostly they will try to hide what that script is about to do. So remember the preg replace. If you look at it, you have no idea what it's doing. You have an idea that it's probably not legit or okay, but you don't know what it is doing. How do we obfuscate? How do we make code harder to read? Usually the opposite of what we're daily trying to do. First of all, remove whitespace. Basically, you minify your PHP code. There's no real purpose to this other than just make it really, really unreadable. Remove all new lines, remove all tabs, spaces, and you get a single line with basically the same function as the above, but a lot more difficult to grok in your head what this is going to do. Start replacing strings. So if you have a string with a secret key, there's a lot of ways that you can write my secret key. You can write it with each character as an effective ASCII representation of that character and concatenating it. You can go with escaped this. You can compress it with gzip, the string, then place the gzip content in it to then decrypt it. Basically, any mechanism that you can use to encrypt and decrypt with the same input and output, you can use to hide your secrets, so to say. Again, you won't do this on legitimate code, but there are a lot of ways to write my secret key. There is, of course, the infamous rotate 13 function as well, which isn't actually obfuscation. It's very easy to bypass this, but there are also rotate 12, 11, 9, basically every kind of character rotation that you can imagine, you can use to hide your scripts. So random piece of code, if you string rot 13 it becomes unreadable. Do it again, and it's readable again. If you have a function or a piece of code like this, it's not readable. You can probably deduce that it's going to do something you don't like. But if you string rot it and then would happen to run eval, you're going to be starting execute. So exec is rkrp, and then wget, and then you basically get this fun script. That is what we mostly see. Someone downloads Perl file, either makes it executable or launches it via Perl, and then Perl takes over from the PHP world. But it's difficult to find this code automatically in code, because you can't just go around grepping for wget or grepping for hack.pl, because it's usually written like this. And this is not something that a simple regular expression is going to catch inside of your code, unfortunately. You can also run PHP within PHP using the eval function. Not sure how many people have used eval in a legitimate way here. 1, 2, 3 hands. It's probably sums it up. Write something like echo Inception, run that in eval, and this is going to be interpreted as PHP code. So it will run, of course, echo and then the code. If you want to obfuscate it, you base64 encode your secret string, decode it and run it through eval, and suddenly you are running PHP within PHP, but obfuscating what you're actually trying to do. Now, if you do this on a really big file and you would base64 encode it, it starts to look like this. So you can have a single string. It's usually, the code that we find is usually has random variable names, random function names, just to scramble with things. But $_ is one that we often see. A really large base64 encoded file, and at the really end of the file, it's going to be eval, the $_ variable, and you execute your scripts, whatever, scanners, are going to have a difficult time finding because there are no keywords to look for here. You need to either decode it or execute it, in the worst case, to see what it's going to be doing. So you can do interesting Inception-like things. Let's say you have 3 variables, underscore, double underscore, and triple underscore. If you run this code, your site is probably hacked. Why? Because we have to look at this from the reverse. Very first function we're going to be running is this one, triple underscore. If we take this string representation, it basically means base64 decode. This string is a base64 encoded string, which will give as a parameter to base64 decode, so we're going to be running this. And in this function, there's a single underscore, which does this code. So every time someone does a post to your system with the code input, it is going to run eval on it, base64 decoded, so what's going to get posted to your system is not going to be readable, it's going to be a base64 encoded string, and then launch that on your server. This is fun code. This is not the kind of code you write on a daily basis, but this is the kind of code that you start to see if you look at compromised systems and see what they drop in. Really fun to dive into, and really fun to try to reverse engineer it without shooting yourself in the foot, by which I mean executing the code. If you want more, I collect these kinds of scripts. Basically, every time a system is compromised and files are dropped on the system, I throw them in a GitHub repository. Feel free to contribute, or try to decipher the code. There are actually a couple of efforts where the uglified version of the PHP file has been uploaded, because that's how we find it on the systems, and someone tries to prettify it, make it functional again with decent variable names, decent function names, to look at basically the before and after of such an exploit script. Now, what kind of fun can you have if you've managed to compromise a website or a server and you've managed to upload your own file? A really interesting and basic concept is that you drop a shell on it, a web shell, so to say. This is essentially a single PHP file that has a file browser. It has a couple of interesting predefined executable code in it. And essentially something that a single file you can drop onto the system and that you can use to start browsing it. And everything that this PHP user has access to, this file is going to be able to read. This looks like it's been built in the 2000s, and it probably is, but it'll still work today. There's also usually some kind of console or a remote access system to it. So a set of JavaScript with just a couple of AJAX calls to the backend to execute its code. You can act as if you're on the terminal, but in a PHP file. You're limited by permissions or privileges to the user that is actually running PHP. You can't suddenly be root. You're probably your website as the username. You're also limited by the php.ini config. So if there are limitations in that config, these will apply here as well. But it can read all of your configs. So we can look at passwords that you had for your Redis, your MySQL, your API tokens for AWS, you name it. Every file that your PHP can read, this file is also going to be able to read. It can also start remote shells, and this is really interesting. Well, I actually find all of these things interesting. What it can do is, it'll bind to a particular IP address and it'll open an additional port on the server. So let's say that your website's been hacked. Suddenly your server is going to get an additional listen port, a port exposed to the outside world if it is unfirewalled, that an attacker can just telnet to, and suddenly it has a shell and it can start typing from the terminal. The fun part here is that it suddenly is a detached system from the PHP shell in the first place. So if you were to remove this file, basically the file someone uploaded to your system, this is still going to work because someone is executing Perl, forking it to the background, and it suddenly has no longer any attachments to the PHP file. So you can restart Apache, you can kill all or remove all your PHP files. This remote shell is still going to be active on your system. It can be used to gain entrance back in. Of course, these kinds of things require Perl, but that is basically installed on every possible server that you can find today. It'll get forked to the background, and it's going to be really hard to find it, unless you do this on a sort of daily basis. So if you manage your own servers and you found one of your systems to be compromised, make sure to check for any running processes that are suspicious, that have opened ports that you did not foresee to be opened. There might be an entry point back. So what, you have your shell to a system, what can you do? It's just a shell, you have limited access. Surely that's not worth much, but I think it is. You can use shell access, so either via the JavaScript interface on such a shell or from a remote shell that has been opened that you can telnet to compile your own exploits. You're usually a limited user, you're the user that is executing PHP, it's not going to be root, hopefully. But many systems have many vulnerabilities because they don't get patched often. So you can probably use GCC, which is a C compiler found on a lot of systems that is hardly ever removed from a system, where you can download C code, compile it, execute it, and potentially elevate your current privileges of a non-privileged user to root privileges. You usually can't do this in PHP, but there is a lot of C code or Perl or whatever code out there that you can use to scan the current system, find vulnerabilities, and then elevate your privilege to the next level. You can also start a Bitcoin miner. This is something that we saw a lot 3, 4, 5 years ago. Doesn't happen that much today anymore because I think people are starting to realize that CPU mining or Bitcoin, even on a hacked system, really is worth it. But this destroys your server in the sense that your CPU is going to be hogged for the full 100%, mining someone else's Bitcoin. Looks like this system has 5 CPUs. They're all running at 100% because someone launched a miner D. The interesting part here is that someone needs to identify themselves because you're going to be mining Bitcoin and then pushing your found Bitcoins to something upstream. You usually can find a lot of usernames, passwords, etc., but they're also going to be non-descriptive. It's not like someone's going to use their actual name in this. But this was fun. You found this on WordPress or Drupal installation that hadn't been updated in a while, that suddenly saw a CPU spike, and were found to be running a Bitcoin miner. Alternative shells are something called the C99 shell, and this is really interesting. It's also one of those shells that I showed earlier. Someone has access to your system, can browse files. But the interesting part here is that there is a feedback form that you can use as an attacker and say, I compromised the system and I used your shell, but this function does not work, and that gets sent to the actual developers of this shell. Now, they had the interesting idea to add a checkbox to say attach server info. So the original system man who wrote this code, this shell, is going to get an email with a bug report to get with the IP address and the URL to the entire shell. So he also has access to your system, and he didn't even have to compromise your system. All he had to do was add a couple of bugs into his shell, hope for feedback, and get it sent to him. So smart guys, dumb guys, they meet in the middle. What do these scripts all have in common? They all have this typical GUI that looks like a 90s hacker movie. That still hasn't evolved. Even with Bootstrap being as universally available as you can imagine, they don't use this. They still use what you just saw earlier. They are true single-page apps, meaning there is a single PHP file that contains everything. PHP file, obviously, the CSS, the JavaScript, images, base64 coded within them. All they have to do is drop that single file on the system and they have their entire application. Granted, it's not a very complex one, but what you call a single page app today is not exactly the same as what we had 15 years ago. They also have a lot of presets, a couple of simple buttons that say, scan the system for MySQL passwords, which will fork in the background and do a lot of complicated things, but the user doesn't need to be smart or educated, and then the system takes over. All of them, and there are a lot of them, basically do the same thing, file browsing, a couple presets, in order to get more access to the system. But these scripts also have clever code. There is code in here that self-updates. Think Composer self-update. You can download a new version from the internet, patch itself, and then expose the new version to the outside. Because maybe there are bugs, or maybe there is something that might give away the identity of the person that wrote it. They'll want to protect themselves, so they are able to push a new version out to the internet. There's also a self-destruct in case the author starts to realize that someone might be on him, to wipe everything. Shells usually make extra copies of themselves, so if you found a single version, chances are there are going to be 5 or 6 other versions somewhere spread around on your directory structure. You won't find the 6th one. All of them have this obfuscated code, the minified, ugly code that makes it hard to read and look at what it's going to be doing. And a lot of them have a system that adds themselves to cron. So if you start to clean up a system and you remove all those files, half an hour later those files might suddenly be back. That's because someone hooked in cron and put it on a system again and you're golden. So don't assume that a single cleanup is going to be the end of it. There are clever ways to get the hack back on the system. Knowing all this, what could and would you do to protect yourself? As a developer, don't trust your users. That's obvious. Wherever possible, whitelist file extensions, never blacklist. This also seems obvious, but this is still the #1 reason we find systems to be compromised, is because there is an upload form that says, don't do PHP, that's dangerous, but that still allow Perl. And never in your code, never say never, but try to never use eval. Eval has a lot of different edge cases and a lot of different ways that it might be exploited. I know there are a lot of template engines that legitimately use eval. Chances are you won't need to use eval. If you needed to use it, maybe the problem is framed in a different way that can see a different solution. As a sysadmin, which is then basically our task here, you can block PHP execution from typical upload folders. So Drupal upload directories, you can block PHP from being executed. Even if someone managed to upload their own files, you can block that file from being accessed from the outside world. You can also block dangerous PHP functions. I'll get back to this later on the term dangerous. You can mount your file systems with no exec, meaning you can't directly execute code, binaries from the file system, even though there are 20 different ways to bypass it. Security is a layered approach, so every layer matters. But probably the best solution is to virus scan every uploaded file. Even if someone randomizes the file, many of these virus scanners, even on Linux, are smart enough to be able to deduce what is legitimate or potentially malicious upload. How would you block PHP execution? You can do this in an htaccess file or in your server configuration. You basically say the directory to which this piece of htaccess would apply, match everything that is PHP or PHP5 or whichever extension you have, and you say you deny it. So basically everyone attempting to browse to that PHP file is going to get a 403 permission denied. If possible, don't do this in an htaccess file, even though it's probably the easiest to get started, but do it in your system configuration. Because remember, an htaccess file is usually uploaded by you. It'll have the same permissions as your PHP code, so writable and readable. If an attacker is smart enough, it can try to read your htaccess file, remove these restrictions themselves, and then upload a PHP file nonetheless. You can also block dangerous PHP functions. Dangerous is, of course, in the eyes of the beholder, but there's a PHP INI config called disable functions that allows you to give it a comma-separated list of functions you do not want to have executed. This only applies to PHP internal functions. So if you write your code and there are, say, functions called hack, you can add this to the list because it's user-defined. It is defined code, which can't be blocked in a PHP INI. things that we usually do are show source, exec, system. Unless the developer or the system needs this code, it's probably safe to start with a locked down PHP before allowing these functions. Now you'll notice that there is no eval in this list, which is probably the one thing you would commonly add, but eval is not a function in PHP. It's called a language construct, and you can't block that in a PHP INI file, which is annoying because it would be a really fun one to block in the first place. Looking at your error or access logs, that is usually something that is extremely boring to most of us, but is worth a lot. As far as it's readable, these are normal logs, so you usually have an IP address, you could have a couple of GET requests, you have the file size, but once in a while you find access logs that start to look like this. Now this is the way that you would find it in an access log. If you URL decode it, so basically remove all the percentages, you get something that looks like this. Now this is where it gets interesting. You probably have a very legitimate PHP file that accepts a query parameter, but then someone starts to add their own queries behind it. These are also things that are automated. This one is done by SQL Map, an open source tool. You just point it at a web server and it goes nuts. And it'll try to read data, modify data, whatever you tell it to do. Also an interesting approach is that you can look at the IP addresses that are hitting your web server. For instance, the first request that you see here looks very legitimate. Someone is scanning your site for an images file and it claims to be Googlebot. You probably don't want to block Googlebot. It's indexing your website. You want to be found. Except that if you look at the IP address, it is suddenly found to be from LeaseWeb. I can tell you that Google does not use LeaseWeb. They have their own systems, a couple of them. But this is someone that just faked their user agent to be claiming to be Googlebot, except they aren't. Usually you'll find scans to blend in to avoid being detected before they start to compromise your system. You can block a lot of these as a sysadmin or even as a developer really, really easily. Now it can never be your only defense. There are proper solutions for this, but this gets you a very long way. For instance, acting on URL patterns. The example I showed earlier has a couple of typical SQL functions that you will find when someone tries to do a SQL injection exploit on your site. If you can block URLs that have character, coalesce, cast in them as get parameters, you can prevent a lot of those automated SQL tools that scan your website. You can act on user agents, so by default, Havish or SQL Map or those open source tools, they'll have a user agent to legitimately say who they are, SQL Map or Havish. Block those in an htaccess file. Say that everything that matches SQL Map suddenly gets denied on your system. The proper approach is to get, of course, web application firewall, something that actually looks at your traffic and decipher legit versus illegal traffic. There's a couple of solutions to this. Mod security is famous in Apache. If you use Varnish, there is security.vcl, which uses a lot of regular expressions to try and match legit versus illegal traffic. And also an interesting one is the 5G blacklist. That's something you'll have to Google. But it's a collection of htaccess files that contain a lot of regular expression that you can just drop into any project. And it will start to block things like character, coalesce. It'll block things like SQL Map in the user agent. Again, this can't be your only defense, but these things, add them on top of each other and they start to add up. You'll want to block brute force attempts. This makes sense, but if someone manages to get access to a user on your CMS, chances are they can upload files and you're golden. As a sysadmin, we use tools like fail to ban to monitor log files and then start to block IP address, but you can use tools like fail to ban in a more intelligent way. Instead of looking at user access denied from an IP address, we can just look at post as a keyword and say an IP address does 20 post requests per minute per second. We'll block it for a couple of minutes because it's probably a bot trying to do something on your system. Of course, how can you prevent yourself is keep everything up to date. Patch everything, not just the CMS, but all your third-party libraries, your front-end code as well. Update your operating system, your applications, and update your own knowledge, your own awareness of how people can take down a system like yours, how they can find exploits within your system. Despite all those precautions, damn it, we've been hacked. Now what? How do we clean things up? Couple of quick hacks, because I'm really simple command line tools like these to find files that say have been modified in the last 10 days on your system. This can be a really huge list depending on your site. It can also be a list of 5 files that just happen to have been modified by an attacker. Overwrite a modification timestamp in Linux. You don't have to trust the timestamp that is there. Someone can fake it for the future or the past. You can also look at your access and error log. So if this command gave you 5 files, look at when they were last modified or accessed, and then start to look at the time from those in your access and error logs. Chances are you can find an IP address, you can trace that back to the initial call and see how they got into your application. And of course, check all of the cron jobs on your system, because a lot of these things have backdoors, if you want to call them like that, that will re-add the code onto your system. Keyword searches also go a really long way. If you have a terminal access, just use grep and find things like eval, base64 decode. This is tricky because it's used in a lot of legitimate code, but if you combine this with this, so grep for both these keywords on a single line, a lot of things start to stand out and you can quickly identify where the hack has been put. There are better solutions. There are malware scanners on a system that you can use or run. These can run as a daemon, so basically in the background, called maldet, clamev, rk hunter. These are tools where they are optimized for this and updated by the community, so you don't have to spend all that much time. And if you uploaded all of your code to the web server, including your Git or SVN history, you can probably do git status and see which files have changed compared to the hash that should have been in Git. That can also give you a proper list to act on. If they did SQL injection, you'll have to be a bit more clever, because in that point all your data is in a database. You can't just grep for a MySQL binary storage, you won't find anything. So take a MySQL dump the file as plain text on the disk, and start to look in that dump for things like inject, script tags, iframe, anything that might be in there. But above all, if someone managed to compromise your system, prepare to assume the worst. If you are unsure how the attacker went, assume that they got root access and just made it look like they didn't, and assume that your entire server has been compromised. It's not a fun thought. It would mean reinstalling things, which hopefully can be done in an automated way, but it is something to keep in mind, that there is a really big scenario that this is going to be needed. And with GDPR approaching, keep in mind that if someone managed to potentially steal personal identifiable information, you will be accountable to mention this to our law enforcement that it happened. So you will have to disclose more details. I want to thank you all for your time, because I'm out of it as well. For the record, we are hiring, so if you ever have an interest, come by and talk to me. And if there are any questions, but I don't know if I have any more time, then you can shoot them at me. Or we can grab a coffee. Your call.
I have a question.
Yes. It isn't. I mentioned Suhosin. I should have added the asterisk at the end. I think officially it's been deprecated.
It's been released.
I think that's a shame. I think it's a really good tool in theory. It's also the only known PHP hardening tool that I know of. But as far as I know, it isn't usable yet. I actually thought it was just dead. But happy to hear that there's a PHP 7 variant. So no concrete experience.
What's your opinion on using web application firewalls like Netscaler or Cloudflare?
To repeat the question, what's my opinion on using web application firewalls like Netscaler? They are golden. They are probably the only proper defense you can have on a system like this. They can't be the only defense. The best defense is making sure you write safe code and update, etc. Tools like Netscaler or Trend Micro has its solutions for these. They look at it from an attacker point of view, which is a point of view most of us probably don't have, and will add an extra layer of security. Absolutely recommend it if you can afford them. It's the other asterisk. Yes?
Just last thing, you mentioned that mostly PHP files are readable and writable. But why would you even make a system when you deploy it that has writable PHP files? Why would you make your server have the permissions to write or that files correspond?
I completely agree. But you look like a smart man. You probably deploy your code with the idea that my code is going to be read-only and particular directories are going to be writable. I think what I'm looking at today is the minority of Drupal developers. Most of Drupal, WordPress, Joomla, every CMS out there gets installed on a system, usually by someone who is technical but not deep technical like us. And that doesn't happen by default. By default, you have writable PHP files or owned by the user, which can make them writable again. So I agree that the best case scenario would be a read-only deployment with very strict permissions on directories where you can add code. But in reality, we don't see that happening, unfortunately. We see that on a nearly daily basis on systems where we don't actually manage the code, but the clients do it. So, any more questions? Then I thank you all.